Right, in part 2 of looking at Newton's second law problems, we're going to look at another type of pulley problem, two-body problem. Now, this is quite a common problem in your examples, but let's have a look at it. In this type of problem, we have one object, A, which is on a flat surface. In this case, there will be friction, and B, which will be free hanging. So, in this type of question, usually you could expect two types of questions. One, to calculate the magnitude of the acceleration. So if we say 1.1, magnitude of acceleration. 1.2, we can expect magnitude of tension in the string. Okay, tension being in the string, acceleration being downwards or to the right. Okay, so what you guys need to make note of is that if we look at the free body diagram of A, we still have the normal force, we still have the force of gravity, but because it's on a flat surface, those two forces will cancel out. The only forces which we are going to be looking at is the idea of the force of friction and tension. Now, in this problem, I'm going to say that the kinetic friction is going to be equal to 0.4 newtons. Right? So that means we've got friction, we need to find tension actually. And then when we look at B, in their free body diagram, it is made up of two things, tension and the force of gravity. Now logically, we have the larger weight on the right hand side hanging, so our direction of motion will be down, and we're going to take our direction of motion as positive. Okay, now how do we start this? Well, we first started with our equation. F net is equal to the mass times acceleration. So then we go into A, where F net will be made up of our two forces. Direction of motion is tension, and force of friction is opposite to that. And now for B, our direction of motion is gravity minus tension. Okay, so in order to calculate A, now we substitute mass times acceleration. Here, the mass of A is 3 kilograms. So it's 3A. Tension we don't know, and friction we do, which is 0.4. On this side, our mass is 4, so it's 4A. The force of gravity is 4 times 9.8 minus T. So in the end of that, we get 4 times 9.8 is 39.2 minus T. And let's rearrange this one quickly. Okay, remember, I'm just taking this across and then swapping them both around. And this one, I'm just moving T across, which makes it positive, and then 4A across, which makes 4A into a negative. So now we have our two equations, 1 and 2. Now, we can substitute 1 into 2, so that means we get 3A plus 0.4 is equal to 39.2 minus 4A. 7A is equal to 38.8 newtons. We don't really need to put the unit in. So then our final answer is A is 5.54 meters per second squared. Right. Now I don't need to give a direction because of the fact that I have asked you to just give me magnitude. Okay, now to finish up this problem, we would have to look for tension. Okay, now for tension 1.2, we can just substitute our value of A into any of the other equations. I'm going to say number 1. So therefore, t is equal to 3 times it by 5,54 plus 0,4, which was the previous equation, and chuck that into your calculator, and we get 17,02 newtons. And that is one example of a two-body problem with regards to Newton's law. The most important thing to keep in mind is direction of motion. Always take direction of motion as positive. Then, by using the direction of motion as positive, then we shouldn't be getting odd answers. For example, our acceleration should never be equal to 9,8 meters per second. That's because if it was equal to 9,8, it is free falling. And if it's free falling, then it's not going to be pulling another object. Also, our tension should never be equal to 0. Because if we have, then you've taken direction of motions as opposite. Okay, so keep those in mind when we deal with Newton's second law.